Hello, today we are going to do the second part of our polynomial graphing lesson. Today we're going to be looking at something called multiplicity of zeros when graphing. So in the fundamental theorem of algebra, it states that zeros can be repeated. So remember, zeros are just another name for x-intercepts. So if an x-intercept occurs multiple times, what does that mean for the graph? Because we can't go through that same spot more than once. So what do? What we say is the factor has a multiplicity of the number of times it is repeated. So for instance, x minus 5 to the power of 4 means that this 0, 5, 0, is repeated 4 times and has a multiplicity of 4. But I can't actually go through the point 5, 0 4 different times. So what we do when we have a multiplicity of zeros is we look at how many times it's being repeated. So for instance, this one was being repeated 4 times with that exponent. And if that multiplicity of a 0 is an even number, then you are going to touch the x-axis, and I'll show you what that means in a second. And then when a 0 is an odd number, you're going to cross. So on this example right here, x minus 5 to the power of 4, if I were to graph this, it would cross through, or go to the point 5, 0. So let's put that 1, 2, 3, 4, 5. But then because it's an even number, it's only going to touch the x-axis. So what would happen is it would come down to this point, and instead of crossing through it, it's going to bounce off, and it's just going to touch it and then go back up. So it's more of a bounce than a touch. It's going to go bounce and then come back off. So let's just practice identifying zeros and the multiplicity, and then seeing if they will touch or cross. And for now, we're going to just look at ones that are already factored for us. Those are kind of the easy ones. You don't have to do anything. So for this polynomial, f of x equals x minus 4 squared and x minus 1 cubed. When it's already factored, you're just going to take each factor, and technically what you're doing is you're setting it equal to 0. So x minus 4, if I set it equal to 0, to solve for x, I would add 4 over, and I would get x equals 4. But most of us just do that in our head now by switching the sign. If this is x minus 4, my 0 is going to be at positive 4. And then if this is at x minus 1, my 0 will be at positive 1, 0. So that's the first part, is just identifying where those zeros or x-intercepts would be. And then now we're going to figure out the multiplicity for each one. So that comes from the exponent, if it's an even or an odd number. So on x minus 4, it's being squared, which is even. Even ones are going to touch. So I'm just going to write even here. And so even numbers, they touch. And then on this one, 3 is odd, and odds cross. So if I graph this one, we'll just do like a quick little sketch. We would have one at 4, would be one of our x-intercepts, and one was at 1. So on the 1, we would be crossing, and then on this one, we would go up and just touch it and then bounce off. And so that's kind of what's happening. So we would have some kind of graph like this. Would be maybe an example. Okay, let's look at another one. So on this one, we have x minus 1 squared and then x plus 2, and it doesn't have an exponent on it, but if it's not written, it would just be a 1. So for this first part, x minus 1, our 0 will be at positive 1, 0. And we do want to write that as a point, as an ordered pair. And then for this one, for x plus 2, our 0 will be at negative 2, 0. For our first binomial here, we have a power of 2, which is an even number, and evens will just touch. And then for the second one, 1 is an odd number, so this one will cross. Okay. So that is how you will do multiplicity. So last time we talked about doing end behavior, turning points, and roots or x-intercepts. And then today we did multiplicity. So now if we put it all together, we can actually graph a polynomial. So to know a polynomial, we need to know the following. We need to know the end behavior, so which direction are the ends going. We need to know the zeros, or the x-intercepts. Remember, that's just another name for x-intercepts. And then we need to know the multiplicity. We need to know if it crosses or touches at a specific zero to help us graph it. So we're going to do a couple examples of graphing. So we're just going to do a rough sketch. It's not going to be perfect. And then we can use a calculator just to check. So for number 3, f of x equals x plus 3 squared, and then x squared minus 9. And we need to know the end behavior for it, zeros, and multiplicity. So just kind of a heads up, today we've only been looking at factored ones. Factored functions work really great for finding zeros and multiplicity, because for the zeros, all we have to do is flip the signs. So one of our zeros here would be at -3, 0. And then on this one, we'll get to this in a second, and then our multiplicity, we would just go based off of the power, right? But for end behavior, if you remember from last time, end behavior, we need to know the leading term, because we need to know if it is a positive coefficient or an even or odd exponent in order to know which direction our ends are going. But in factored form, we don't know our first term. So rather than actually sit and multiply this all out and FOIL it, I'm going to show you guys a little shortcut. What you can do is essentially, if we FOILed this, this guy is being squared. So if I times it, I would get x times x, which would become an x squared. So this section would give us an x squared, and this section already has an x squared, right? Well, if I times those together, we would get an x to the 4th. And since their coefficients would just be like a 1, they don't really have a number in front except for a 1, there's not going to be a coefficient except for a 1 in front of the x to the 4th. So if I did multiply and FOIL everything out here, our first term would be x to the 4th. The thing is, we don't need all the other terms, we just need that first term. So this is just a shortcut to save you time, so you don't actually have to go and multiply all of that out. So just count the x's. I have an x squared in this group and an x squared in this group, and then if I times those, became an x to the 4th. So for end behavior, if it is an even degree, remember even ones are going to go in the same direction. They're either going to go up, up, or they're going to go down, down. So then to figure out which one of those you have is that coefficient. Our coefficient would be like a 1 here, and it's positive. Positive coefficients are going to go up in both directions. So our behavior is going to go up to the left and up to the right. And then for our zeros, we already got one of them, but then this one's not factored all the way. If you notice from our polynomial identities lesson that we did a couple lessons ago, this is actually a difference of squares. We have a square subtract a square. So it's not factored all the way. Sometimes you might need to catch that on your problems and do the factoring. So x squared minus 9, since it's a difference of squares, it's like having a squared minus b squared. It's going to factor, you guys remember how to do it in your head? When you have a difference of squares, you're going to factor it to be 1 a plus and 1 a minus, and then you're going to have an x and an x for taking the square root of the first term, and then the square root of this term. Square root of 9 is 3. So we have an x plus 3 and an x minus 3. So that just changed our problem quite a bit, right? Because a really easy mistake would have been to say that I had a 0 at just 9. But we have that x squared there, not an x. So we had to refactor it. And this one was already an x plus 3. I just added another x plus 3. So now instead of having 2 of them, I now have 3 of them. And now I have an x minus 3, which would mean for my 0, I now have a positive 3 down here, since we switched the sign. So that's a really easy mistake to make, is if you forget to factor this and you say, oh, my 0's at 9, and then your whole graph is going to get messed up, because not only will you have the wrong 0, but you also would have had the wrong multiplicity because you would say it has a multiplicity of 2 for this one when really it's a multiplicity of 3 now. So if we go and do the multiplicities here, I'm just going to draw an arrow down for these. For -3, remember, instead of having an exponent of 2, we now have 3 of them. We have 2 here plus 1 here. It has a multiplicity of 3, which is odd. And since it's odd, it's going to cross. So again, if I had messed this up and I had said it was just a 2, I would have said it's even and it touches. My graph would have been totally wrong. And then on this guy, x minus 3, it doesn't have an exponent. It's just an exponent of 1. 1 is also odd, and so it will cross as well. So now we're going to put it all together and do a little rough sketch over here. So how I like to go through and draw mine is I like to first put where my zeros are. I just go and put points. So we have one at -3 and one at +3. And then I like to draw the ends. So I know my ends have to be going up. And then we're essentially kind of just connecting the dots here. So on both of these, they're crossing. So I know this arrow, the left arrow, has to somehow connect to this point, right? So then I go down to that point, and I know this point crosses. So I'm going to cross, but I have to get back to this point in this arrow. So I'm just going to bend, and then this point also crosses. So I'm just going to cross it, and then I'm going to connect back up. So this one was kind of an easier one because it was just a simple parabola here. So that is going to be how you do your zeros and your multiplicity. Let's try another one that might be a little bit more difficult. Okay. So on this one, we have some more going on and also some higher multiplicities. So for end behavior, again, we're going to do our little trick. We need to figure out how many x's we have total. This would be like an x to the 1. Then here we have an x to the 4th. This is like a negative x to the 1. And then this would be an x cubed. So if I times all 3 of those together, we would get an x times an x to the 4th times an x cubed. Remember, we add those exponents whenever we multiply. So 1 plus 4 is 5, plus 3 is 8. But we do have that negative that came from this first one. And that negative is going to be important in telling us our end behavior. I'm sorry, I just knocked my camera. So, let me fix that really quick. So for our end behavior, this time we have an even degree. Remember, evens either go up, up, or they go down, down. And then to know which one it is, you look at the coefficient. So we have a negative coefficient this time. Negatives are going to go down. So our end behavior is going down to the left and down to the right. Okay. Now we can get our zeros. So looking through here, we don't have anything to factor since this is just an x and an x. Versus on this last one, it's kind of getting messy up here, that was an x squared. So that's kind of a good giveaway when you might need to refactors if you have an x squared. So since these are all just x's on the insides, we can't factor anymore. So we can just go ahead and get our zeros. So on this first one, we don't have a number with it. This is a mistake I see a lot of students make on this section is they think that this one doesn't have a 0 with it and they would just do the 5 and the 2. But whenever there's not a number with it, your 0 is at 0. So we do have a 0, it's just at 0. So another way you can think of that is, remember, whenever we're finding zeros, the reason we call them zeros is because what you're technically doing is you're taking that part and setting it equal to 0. And for a negative x, all we would have to do is get rid of that negative by dividing by a -1. So that negative goes away and we just have a positive x. But 0 divided by -1 is still just 0. So don't forget about those x's that are out in front without a number. They still have a 0 or an x-intercept. Their 0 is just at 0. But then on this section, x plus 5, the 0 is going to be at -5. And then for x minus 2, the 0 is going to be at +2. And then we can look at the multiplicities. So this negative x didn't have an exponent, so that means it had a multiplicity of 1, which is odd. So that means it is going to cross at that point. For negative 5, the multiplicity was a 4, which is even. And evens are going to touch. And then for 2, it has an odd multiplicity of 3. So this one is going to cross. Let's see if I can write today. Okay. So once we have all that information, we are good to now kind of connect everything into a graph. So remember, our ends are going down, and then I like to put these points first. So we have a 0 at 0. We have one at negative 5, and we have one at positive 2. And then our ends are going to be going down and down. So I need to connect my points going to the downward arrows. So I usually like to just go left to right when I do these. So I'm going to connect this left dot, has to meet up to this first dot. And then at negative 5, let's check and see, are we touching here or crossing? So at negative 5, it was even, so we're touching. So rather than cross through, we're going to bounce away. But this graph has to now meet back to this dot. I have to get there. So I have another turning point, and I meet this dot right here. So then I look at 0, and I see I cross. So this one is going to come through, but I have to meet back to this point. So now let's look and see at 2, what do we do? And at 2, it was an odd multiplicity, so we cross. So it's going to cross, and then I have to connect back to that arrow. So you have kind of like an M shape here. So that is how you will graph those. Hopefully that helps, but again, just kind of my warnings that I see mistakes with students. I see mistakes when they have to factor and they forget to. So a good sign there is if you have an x squared, you probably need to refactor it. So that was a difference of squares. So that's probably the most common one you will see is a difference of squares, where you have a square subtract a square. And remember, to factor that, you're going to have one group be a plus, one group will be a minus, and then just take the square root of each of these, and that goes on the inside. So square root of x squared is x, and the square root of 9 is 3. One will be a plus, one will be a minus. So you'll see those a lot. And then the other mistake again is when you have that x out front, people will forget to give a 0 to this. And so they would have just said, oh, I only have 2 zeros, but really we have 3. So don't forget that if it's just an x, the 0 is just 0. So we need to include that point. But those are probably the main mistakes that I see. So that is going to be your graphing by hand. Let me know if you guys have any questions. As always, just please reach out to me via email or through Canvas, and I am here to help. Hope you guys have a great day. See ya.